Yeah, so Paul will be giving a talk over the novel input and output opportunities using an implanted magnet.
Let's see. Do you?
We see plants now. Now we see.
Yeah, you see some coins here, right?
Yeah.
It's odd because I don't see my own video. Okay, hello everyone. Before I start, I want to show you a bar trick that I do. What I usually do is I get some random person and give them some coins, and I say like, focus all your energy on these coins. And then I say, look, you're magic, you've energized these coins because now they're attracted to my hand, right?
What?
And the reason why this works is because there's a magnet in my hand. So this is a cheap bar trick, but I actually do have a magnet in my hand. So let me share my screen. Share screen. And here, go to my presentation. So this is my hand. And this is my magnet. I've had this magnet in my hand for, I don't know, 9 years. I'm a body modification artist who I know implanted it. But the reason it's at that location is because I work with electronics. I work with sensors, and I didn't want it in my fingertips. The reason why some people put it in their fingertips is if the magnet vibrates, you feel that. So let's explain that. What you see here is my phone, and then there's a coil underneath it that gives electromagnetic pulses. And there's a magnet in some water. It's just something I recorded a while ago. And you see the magnet is jumping around. And the reason the magnet is jumping around is because we're creating an electromagnetic field with the coil. Similarly, the refrigerator creates an electromagnetic field, or various devices create electromagnetic fields. And these will move the magnet, and in my case, I can feel that in my hand. Some work I did a while ago is a friend at Implanted and colleagues in Copenhagen and I, we got the device you see here. This device can track the position of a magnet. And it can also actuate a magnet by sending electromagnetic pulses. We kind of thought, okay, we might integrate this in a smartwatch, or we demonstrate that it could be integrated in a smartwatch. And the idea is that you can maybe glue a magnet to your fingertip, and it will track your fingertip and give you haptic feedback at the same time. Okay, so what does this paper do? In the current paper, which is work that I did with just McIntosh, kind of follow-up work on our white paper, we look at, okay, so if we take such a system, what can we do with an implanted magnet? And there's actually a lot of stuff you can do. So for input, like one example, I might move my smartwatch, and because the distance to the magnet changes, I can use that as an input. So maybe the position of my smartwatch on my arm could be input to the system. This is something which is really hard to detect using IMUs and most other methods. But you could also do simple motion capture or gestural input. So here the angle between the magnet and the device changes, and I can sense that. And these things together allow you, they enable a bunch of interactions with wearables which otherwise would be really hard to do. And here I'm showing a smartwatch, but I imagine this could be done with jewelry, this could be done with clothing, this need not be a smartwatch, it's just, this is an example we're familiar with. And the other thing that I show in this paper is how can we provide feedback through that magnet? How can we use that magnet as an output device? And what I'm showing here is a response curve to opinion cells. These cells, they respond to vibration. And if we look at this graph, what we see is that at about 250 hertz, the lowest amplitude for feeling vibration is required. So let's say I'm vibrating something at 250 hertz, and I'm making it so the vibration so subtle that you can barely feel it. If I increase the vibration to 320 hertz, I need to increase the amplitude of the vibration. And if I decrease it, I also need to increase the amplitude of the vibration. So 250 hertz is kind of where we feel stuff, where we feel tactile information with Pacinian cells. And if I make it go higher or lower, we don't feel anything. Or first we feel less and then we don't feel anything. I repeated, so this data is from a paper back in the 60s. And there's a ton of papers that show these response curves. Jess and I, we repeated this experiment, or a very similar experiment, with the system that I showed before. We used a different methodology. Instead of measuring the level at which you feel something, we measured how strong you feel something. Measure is maybe the wrong word, we simply asked. And what we would expect to find is the inverse of this curve. What you see here, the blue line is the average of what we found, and then the red lines are individual response curves. And it's almost the inverse, it's not quite. So we'd expect the inverse to maybe look something like this. And there's a little bit of a discrepancy here from the other, from this one. But basically, in the system that I showed where the fingernail is being tracked and actuated, everything is as we would expect. The vibration is mediated through Pacinian cells, and the Pacinian cells react as we would expect them to react based on the literature. Right, so this is the data we recorded, which was not very surprising. I then conducted, or I should say Jess conducted the same experiment with me as a single participant. And I expected to find the same thing. What I found was this here, which was surprising to me. That didn't make any sense. So what we see in this graph is that yeah, how should I put it? So here at around 333 hertz, there's a maximum, and here it's not very strong at all. And if I make the frequency be higher, yes, the slope is reduced and I feel less. But as the frequency gets lower over here, I feel it very strongly. That is not what, that doesn't really make sense. So we decided to do this experiment again in more detail. And we did many more trials, and we a wider range of frequencies. And the result that you see is this here. And to put this in context, assuming I would feel it with the Pacinian cells, this part where the frequency is reduced would make a lot of sense. But the yellow line is the expected response curve of how we usually perceive vibration that is applied externally. And then there's all this here, which just makes no sense. It's not how vibration usually is perceived, which is really, really cool, actually, because it shows, you know, something inside the body is perceived differently than something outside of the body. We played with this some more and wanted to see, like, does this difference in perceived strength lead to a difference in experience? So some of the things we tested, we did magnetic decimation studies of perceived sharpness. And again, so what makes sense is that, I mean, I should qualify this. This data is way too much all over the place to make any strong conclusions, but what makes sense is here that as frequency increases, sharpness increases, because that's something that I found in a previous paper already. So this part makes sense. And again, all of this, I just should not feel anything there. And then another experience that we looked at was the sense of deformation. So I felt that when my hand was being vibrated, it felt like something was pushing or pulling against my hand. And this pushing and pulling sensation was really strong in the low areas, which is really cool to me because it shows that with implanted devices, we can create sensations which would otherwise be difficult or even impossible to create. I should maybe justify all of this by also explaining that when these experiments were done, I had no idea what specifically was being tested. So Jess conducted these experiments on me, and I was literally the participant here. Okay, so what can we do with this? There's a large body of literature which links material experiences with motion. So what this means is I'll get to that in a moment. I'm very disoriented by not having an audience. And for me, like seminal papers that look at that, or for example, the paper by Romano and Kuchenbecker to create virtual textures from contact acceleration data. What they do is they record a pen moving over a surface. They record how the pen is vibrated, and then they play back these vibrations. People who are moving a pen over a flat surface. And what happens is people experience these textures. Another example is by Johan Kildal, who looks at vibrating a surface relative to changes in applied pressure based on people pressing onto a surface. He demonstrates how the synchronization between pressure dynamics and discrete haptic impulses can create the experience of compliance. So you feel that something is pushed back. And then me and some colleagues, we tried a whole kind of battery of mappings between motion and vibration, and you can create experiences of weight and of friction and counterforce. And there's all these novel experiences that are created when you generate tactile feedback based on user motion. The reason why that works is simply because that's how our perception works. So we have a fingerprint, and the fingerprint has a structure. And if we move this over a structured surface, the interaction between structure of our fingertip and the structure of the surface creates vibrations. And these vibrations are what we interpret and what we use to create an experience of texture. So it makes sense that our sense of material experience is linked to motion somehow. And the reason this is cool is because with this magnet, I can both track the location and I can also actuate it. So what I would hope to do with this kind of thing is right now we have a breadth of things that we can experience, like light, sound, and temperature. And then there's all kinds of things out there that we don't experience, but exist around us, like the Wi-Fi, which is enabling me to communicate with you guys. There's UV and IR coming at me from the windows. These things we can't experience, but we could make them experiencing if we create these synthetic material experiences. And then, of course, there's stuff like data transfer, or stock markets, or the Pokemon Go example, which exists out in the world. They're not really physical. And again, like how can we create sensory experiences of these things, which have kind of the same qualia as our other everyday experiences have? But that's completely looking into the future. Anyway, this is what I have to say about. Let me go back to stop video sharing. What I wanted to do is I want to share with you that with a magnetic implant, you can track the position of the magnet, and you can use that as input, and you can actuate the magnet, and you can use that as output. And because you have both the tracking and the actuation together, you can actually use that as the platform for creating synthetic material experiences. And that's what I have for you today. Anyway, thank you very much.
Thank you, Paul. So do we have any questions?
Hi.
Yeah.
Are there other people with implanted magnets
Yes.
to
This is
replicate
not
the study?
There's actually a study done with, I think, 8 people with magnetic implants, which has a completely different methodology and looks at different things, but their data and my data agree with each other. But it's hard to, like, it's somewhat incongruent because they're doing very different things. But if you look at them together, it somewhat makes sense. It's a paper by Kevin Warwick and a guy called Harrison. And so people have started implanting magnets sometime in the 90s. And it's in the body modification subculture. It's kind of a not very special thing. So I spoke with a piercer recently and I asked her who in Saarbrücken implants magnets, and she said, oh, nobody, but there's a guy in Kaiserslautern. So it's not as outrageous as it is to most people when they first hear about it.
Mm-hmm. Do you have an idea what cells are actuated by the magnet? Because when the Pacinian corpuscles, as you said, the range doesn't really make sense.
I should be prepared for this question, but I confused the names. But there's basically 2 types of fast adapting cells. And there's another type, I can't name anything right now because I'll say the wrong thing, which reacts to lower frequencies. And I believe it's mainly relevant for edge detection. And it would make sense also with the pushing and pulling sensation, that is that cell, but that's just speculation. It could honestly also be all kinds of other things because, I tried it on myself with one specific system. And I try to be as diligent as I can, but I can't really I can say like, yes, it looks like it's this other cell, but I can't confirm that.
Sure.
I'm also not sure if it's important or not, but
it's just,
I don't know. Yeah.
And we have a question from Aaron quickly.
Yes.
Have you measured any force levels on the magnets?
Should we, Aaron, do you want to be here so I see you? No, because I'm not sure what you mean by force levels. Do you mean the force that the magnet applies on my skin, or do you mean the force that I experience? No, I don't know how to measure that. I think I would need to implant yet another device into my hand. I don't know that. It would be interesting to compare that.
And Shoya has a question.
Yes, I just posted.
Yes.
I'm really curious about how did you decide the position to implement?
Yeah,
yes.
If you take a map of your hand, then the fingerprints or the fingertips are the most sensitive.
Yes.
And that is where people usually implant magnets. But I go climbing, so I want my fingertips to be strong and I don't need to worry about, doing something stupid. And I work with magnetic sensors, so I don't want them on my fingertips either. So that was completely out of the question. And then compared to the rest of the body, this surface is very highly innervated. And I decided for this area because there's like a big fatty cushion which protects it. So even if you touch it everywhere, you will never feel it. And that also means that the magnet cannot be damaged and it's far away from my fingertips. It never interferes with my day-to-day activities. It does mean that I feel a lot less than the people who do implant it in their fingertips. So I'm not that sensitive because it has also migrated underneath this fatty tissue, which puts it quite far away from the cells of the skin.
Okay.
So I have a very short one. Did you encounter any situation after you implanted the magnet which felt odd for you? For example, you felt things in your everyday life which you never felt before. Or for example, if you go through a metal detector check at the airport, which is then tells, okay, this person has a magnet somewhere, and then you get extra checks, for example?
So there are
So
magnets in the elevators. Do you feel the elevator magnets?
Yeah, for example. So
I typically, static magnets I don't feel. So when I was doing my party trick, I actually added another magnet in so that I have more strength, so I can put this magnet here. I don't really feel the magnetic field, I just feel the pinching force. What I do feel is if I move this magnet very fast, I feel the magnet inside of my hand move. And the first time I have an engineer friend and I told him about the implant, and he said, so what happens if a really strong magnet touches your hand? And I said, I don't know. And he handed something to me and I took it and it was a super strong magnet and it flipped the magnet inside my hand. And that felt like an object inside of your body flipping. But in terms of experiences in everyday life, I've walked past a wall and I could feel that there's some super strong motor or transformer behind it, like a massive transformer, just some random wall. And I have no idea what's behind it, but like I stopped for a moment and then I walked past and back and forth because I had never felt something as strong behind the wall in general before. And that was just really interesting that all of a sudden I was like, there's something back there and nobody else will know about it. And I don't know what it is. And I was also working with electromagnetic tracking systems. These are used for medical devices where they, for example, track the position of a probe inside your body. And the system that we were using, we completely hacked it to track all kinds of other things and it would always crash. And I was the one who could debug it the fastest because different ways of crashing felt different for me and I could identify which crash it was and how to fix the crash. So those are like two experiences that were kind of interesting.
okay, cool. Thank you.